Alright, so this is my little video on my process for porting this head. This is a BP4W head off of a 99 Mazda Miata. It's going on my 1993 Ford Escort GT with a big stupid turbo on it. Looking for around 450, 500 horse. Could do that with a stock head, honestly, but since the head's off the car, why not free up some power? I am not a professional. I am not a, hey, what's up? So, anyways, yeah, I'm not a professional. Take everything I say with a big old grain of salt because I could be completely wrong. I'm only regurgitating things I've heard off the internet and things other people more knowledgeable than I have told me. So, first things first, as far as porting this head, I'm not going to go nuts with it because, like I said, I don't know what the hell I'm doing. So, so yeah, as far as porting this head, there's like a lot of science and stuff that goes into a lot of science, a lot of knowledge, a lot of witchcraft that goes into porting a head and doing it, correctly. You got to worry about, runner ratio and valve angle and blah 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 and all this stuff and sealing floor and a bunch of terms that I don't know what means what. It used to be the general consensus used to be the bigger the better, but you make the runners too big, you decrease velocity, and you may actually lose power by having the runners too big. So, with that in mind, the BP4W head is one of the better flowing heads for the Mazda BP. It's the best flowing head next to the VVT head. I think the VVT head may have the same design, just has VVT. But anyways, Mazda did a pretty good job re-engineering the head for more flow and more performance. So with that in mind, I'm not going to do too much cutting. I'm only going to do cleaning. So when I say cutting versus cleaning, what I mean is cutting would be removing as much material as possible. I'm not going to do a bunch of that. Cleaning, what I'm going to do is try removing all the factory flashing and casting defects and stuff like that. So yeah, we take a look inside. We can see all types of flashing and that really rough, if I can get this to stay where I want it to stay. There we go. Alright. So you can see all this roughness. That's all from the factory sand cast. Mazda basically made, alright, so like Mazda basically made like zero effort to clean that up after the casting. So yeah. So basically what I'm doing is I'm just going in and I'm cleaning all that up and I'm smoothing out the inside. It looks smooth, but that's like 80 grit. It's not super, it's not a mirror finish. There's still some texture. There's some theories about whether or not you should go mirror finish or if you should leave some roughness. I believe the idea, from what I've read and from what I can gather, the idea behind leaving some roughness behind is to help fuel atomize better, but I think that's more so for naturally aspirated and more so for carbureted vehicles. Because when you have a carbureted vehicle, fuel is basically dripped into the intake at a fairly low pressure, and all that atomization is done inside the runners. It's all, so you need that roughness, you need that turbulent air in order to get the fuel to atomize properly. In a fuel injected car, especially a turbocharged car where the line pressure is going to be like 100 and something psi, the injector atomizes the fuel. It's already atomized. You don't really have to worry about it falling out of suspension as much as you do with a carbureted vehicle. Once again, not an expert. This is just what I gathered myself. This is just my thinking behind it, So I think leaving a rough finish is less important on a fuel injected car, on a EFI car. So I'm gonna smooth it out. I'm gonna do them all kind of like I did this one and leave it. Like I said, it's not super smooth. It's not mirror finish. It's still rough. I can still feel machine marks in there, but it's probably smoother than what most people would recommend. But I don't think it'll be a problem. And if it is a problem, it'll only be a problem at idle and low RPM, which I don't care about because this car's meant for drag racing. So it's gonna live you know, 6,000 to 8,000 RPM. That's so. Like I said, I don't think I gotta worry about fuel falling out of suspension at that high of a pressure at that high of an RPM. All right, so just to reiterate, I'm not opening this up a whole lot. I'm going to try to remove as little material as possible, just enough to clean up the casting. I will be removing some material around the where the seat meets the runner. Let me show you again. So, if we take a look in here, we can see, come on, doesn't want to focus at the back. So you can see where the valve seat meets the runner, right in there. There's a little bit of a lip. It's not a very smooth transition. It's the same on all of them. So I'm going to do what I did on this one, which is smooth all of that out. You can see that is basically level. I actually cleaned out a little too much there, but yeah, I'm going to make sure that the seat is perfectly aligned with the runner. That'll help flow a lot. I'll be opening up the throat a little bit, like I did with this runner. By throat, I mean just the opening of the seat, not the actual mating surface where the valve meets the seat, but just where the seat meets the runner would be the throat. So that'll be opened up very slightly, not removing a lot of material, because like I said, I don't know what the hell I'm doing, so I'm just a guy. I'm a guy with a Dremel and time. So what I'll be using, I guess first I'll talk about this. So this is a little kit Summit Racing sells. I think Standard, Abrasive, and a few other companies sell a kit like this. About 30 bucks. Comes with these nice little sanding drum, sanding disc. A couple different grits. I believe it's, I believe it's 80 and 120. Oh, there's 60. So 60, 80, and 120 grit. So then you could use like an arbor or a burr bit. You know, you could use something like this. This is more so recommended for if you're really planning on taking a lot of material out. This one wouldn't be ideal for aluminum, by the way. These get clogged when you use them on aluminum. So there's some different burr bits like this that have bigger spacing that are better for this. But these are really aggressive, especially on aluminum. You can do some damage if you're not careful. Speaking of doing damage, when you're doing something like this and you do decide to hog this thing out to be as big as humanly possible, you have to be aware of the fact that there are water passages and there are oil passages inside of this head. And if you take out too much material, you could enter one of those passages and completely ruin the head, which is another reason why I'm not taking out too much material. According to the Mazda guys, there's a really good write-up on, I think, Miata Turbo, where a guy took one of these heads and he actually sectioned it. You know, he cut it open. He had a spare one, and so he could actually see just how much material he could remove and stuff like that. So I don't have all that information, so I'm gonna go mild, you know. So anyways, something like this, you know, something like this with these types of bits. I guess I could get in the light there, huh? It's probably is best for aluminum headwork. The other thing I bought were the standard abrasive 1-inch cross buff pads. These things are amazing. These are great. These are great for finishing. So after you do your cuts and you rough everything out, you can go ahead and follow up with these guys. I got two different. I got a medium abrasive and then a fine abrasive for the final polishing. And when I say polishing, I don't mean polish, but you know, for the finishing, you know. So, but anyways, yeah, these things, they're like 16 bucks for like 10 of them. Freaking amazing. So when you buy these, you have to buy a bit for them, a mandrel for them. It's like 16 bucks as well. It just screws onto the top. So it just screws on like so. but yeah, these are great. So you got your sanding kit, your finishing kit, and then you have to decide on what tool you want to use. You can use a air die grinder. This is traditionally what's always used. They're fairly cheap. You can go down to Harbor Freight, get yourself one. Problem is you need a pretty big air compressor. I have a 21-gallon air compressor, and this thing will drain it in probably like 5 minutes, if that. I mean, less than that. So when you're using something like this and you have a fairly small air supply, when I say fairly small, I mean like 21 gallons, that air compressor is going to be running non-stop the entire time you're doing this. This is going to take you hours and hours and hours. So when you're using something like this, you're going to be dealing with a lot of noise. These things are noisy, insanely noisy. Air compressor's noisy unless you got a real nice one. So if you use this setup with air, a pneumatic setup, ear protection's highly recommended because you'll be deaf by the end of it. Because of that is why I went and I bought this. This is a Milwaukee Die grinder. They are about 169 bucks. They use the M12 battery pack, so they're 12 volt. They say, I think the top RPM on this is 22,000. So it has 4 speeds. So you can set the max speed, but it's also a variable trigger. So you can really control your speed. If you're used to using one of these, this will come very naturally to you. So if you plan on doing this and you don't have an air compressor, this is a really good option. 169. Well, if you don't have the batteries, it's 259 bucks for the tool and 2.0 batteries. These are 3.0 batteries. So the tool and 2 amp hour batteries, 259 bucks. But I think just for how quiet this thing is compared to the air, when you combine just the sound of the tool and the sound of the air compressor, this is just well worth the money. And from what I can tell with the 3 amp hour batteries, I did this entire runner, like start to finish, from this to this, on one battery, and I've only dropped 1 bar. So that's pretty phenomenal. Obviously, battery life will vary depending on workload. If you're really getting into stuff and really putting a lot of load on it, it'll probably drain the batteries a lot faster. But I honestly think I could probably finish this whole head with like 2 batteries. But I have 4 on standby just in case. There's always a battery and the charger, so I think I can charge a battery faster than I can drain one. So I'm not concerned about running out of power and then not having anything to do. So anyways, with that, I'm gonna go ahead and get to it. I'll probably just do this as a time lapse. Probably won't talk a whole lot. Just get in there and show you how I do. So another thing about this Milwaukee Die grinder, I don't know why I'm so obsessed with it, but like, I think one of my favorite things about it, and it's gonna sound stupid as hell, are the wrenches that come with it. These things are beefy. They are like really solid wrenches compared to like the type of wrenches you typically get with a die grinder. These little stamped out steel pieces. These things are like super solid, will last forever. Super wrenches, The other thing I like about this die grinder is the collet. The collet is actually captive inside of the cap there. So what happens when you loosen this up, it actually opens this guy up so you can just slide your tools right out. You don't have to, you don't have to fight to try and get them out, because it will actually pull the collet out of the cone and make it easier to remove your bits. So yeah. Alright, so first thing I'm going to tackle is I'm going to get all the bowls cleaned up. Rather than working on one at a time, I'm going to kind of do them all at the same time in stages, so that way I'm not changing tools a lot. I don't have to change my method or technique or keep flipping the head back and forth and stuff to get to different areas. So I'm going to flip the head around. All right. All right, so yeah, what I'm going to work on first is getting all these areas cleaned up. Well, this one's already done, but getting all that cleaned up and working down in there in that little bowl area, getting that cleaned up, and then the back half will be fairly simple after this is done, because this area is the most time consuming, so you gotta be careful not to mess up the seats. And so I've got two different mandrels for the cones for the sanding disc. So I got a long one, and then I have a short one. So I think I'm going to use a short one, just for getting in there. So when you're in here and you're messing with this, right? So which one am I? So yeah, when you're in here and you're messing with this, you want to make sure that the abrasive part of the disc, you want to make sure that the abrasive part of the disc doesn't touch the mating surface on the valve seat. So the mating surface is that like outside diameter there, you know, because if you grind away at that, you might as well just go ahead and take it to a machine shop, and you're going to have new seats pressed in. So you gotta be very careful with that. You gotta make sure you keep an angle so that you're not going to touch where the actual valve meets the seat. So I'm gonna go in with a 60 grit and get all that cleaned up. Backlighting the valve helps a lot too. Just stick a light on the back side over there. Right, how you do? So I want to try and explain my mindset as much as possible. So, like right now, what I'm working on is just smoothing the transition from the runner to the seat, and opening the seat up ever so slightly. So, like I said before, there's a lip at the top here, the bottom of the throat, or bottom of the runner, the floor, where there's a bit of a lip, and I'm just going to take that lip off. Already, that's all that took. That's nice and smooth now. I almost touched the valve mating surface. I went down there and I touched, yeah. Gotta be careful, don't want to do that. Gotta be very careful. So the rest of that floor I can get from the other side. I don't have to try and smooth that out, but that little bit of that lip right there, you definitely got to get from that side. Another thing, talking about this tool, this Milwaukee Die grinder, the fact that there's no airline allows me to just move this thing any way I need to get in there and do what I need to do. So I'd say it actually makes the job a little easier. So I'm going to go ahead and knock out the rest of these, the top half, and then I'll come back in when I flip the head around and get to the other side. So I finished cleaning up all the critical areas, so now I can just go ahead and move on to the runners. Same kind of thing. I'm going to use the coarsest grit I got, which is a 60 grit. I'm going to reuse the drums that I was using to do that, because basically when I did the seats, all I did was kind of use the tip of the tool there, so that's kind of worn down, but the rest of it's still pretty good. So plus there's multiple layers. So anyways, I'm just going to go in and start cleaning up the castings in there, and so on and so forth. Down to one battery, or one light now. Alright, so basically what I'm going to do that to all of these, and I'm going to flip the head up on its end so it's laying on the exhaust side, and I'll get the floor of all of these, because I didn't really get those very well because I can't see them. I kind of brushed them a little bit, but didn't really get in there. So I'll do these other two on the bottoms. Again, rough cut it, flip it up on its side, get the floors, and then I'll start doing the finishing cuts, the polishing. Alright, so now I'm going to work on the floor of the runners. Obviously with it angled this way I can see the tops of the runners a lot easier, or the bottoms of the runners. I'm trying to avoid sitting the head down on the mating surface, the business end. Even though there's masking tape protecting everything, I don't want to risk putting it on something, because the bench is covered in metal shards, and I just don't want to risk sitting it down and having something go through the tape and damage the finished surface of the head. So yeah. Also, we're still at one bar. So one battery has done basically almost all the intake runners. So yeah, one battery has basically done almost all the intake runners on the rough cut. So it's pretty impressive. Alright, so now I flip the head over again and take side down. I'm going to be working through the seats. Once again, got to be real careful just to get some of the areas that I couldn't quite get at from any of the other angles. So yeah, while the head's like this, And I can actually show you what I was talking about earlier with the transition. So, stupid light. Oh, that should be bright enough. So basically, like this transition here, going from the bottom, this edge, used to be really sharp. It wasn't curved. It just went straight down. And it was just a very jagged transition. So what this does is this will smooth that flow out a little bit. So now that I got that done, I'm going to, before I could try a smoother one of these guys, you know, the drums, but I'm going to try I think I'm going to try this out. Actually, you know what? No, I already tried that. Alright, so now I'm going to go through with a smoother grit. Clean this all up a little bit more. Alright, so now that I got all the roughing end done, you can kind of see how that looks in there. But yeah, so now you can see how that looks in there. That's when it's already been like polished. But these have just all been roughed. So what I'm going to do now, alright, so what I'm going to do now is I'm going to go in with the cross buff tool. These little pads are just basically little abrasive like Scotch-Brite pads, but they're in nice little round little deals. So you can just screw that onto your tool. This is the high abrasive one. The blue ones are medium. And I can just go in there and start cleaning this up more. Oh, I actually got it backwards. The red ones are the fine ones. The blue ones are the more aggressive. That would explain a little bit. There's that difference. They are not perfect by any stretch of the imagination, but they're a lot better than they were. So the OCD part of me really wants to go back through with more of a sanding disc and really doing my best to smooth it, you know, to get it as good as it possibly could be. But I'm not, because it's just not, it's not really worth the effort. I'm going to go back to this this red one here. Alright, so with that, I think I'm going to go ahead and call the intake side done. Because I'm not, like I said, my intent isn't to go nuts with it. You know, I just want to, just kind of wanted to clean them up a bit. So, they're all nice and clean. No more casting flash. There's still some pitting. But I don't want to grind away so much to get rid of the pitting. So, I'm going to call that side done. So I'm going to move on to the exhaust side. Basically the same thing. Not going to film that because it's exactly the same thing. And I just want to jam out to some music and knock that out. So, alright, so this is basically the finished product from start to finish. It's not perfect, you know, but it's definitely a lot better than it was. So this is the exhaust side. So yeah, like I said, it's not perfect, but it's definitely a lot better than it was. And this is intake side. Kind of see down in there. So now what I gotta do is lap the valves and take this thing outside and hose it down, make sure it's completely clean, get all the stuff out of it, and then yeah, you can move on to putting the thing back together. But this will probably be it for this video, and yeah, till next time.